Welcome to another video analog device circuit. Today I'm going to discuss about clamper numericals. So as already I have discussed in the classes or in the previous video lecture about positive clamper, negative clamper, positive clamper with positive bias, positive clamper with negative bias, like that. So today in this numerical we are having a resistance of 10 ohm and a reference voltage or bias voltage we have given as 2 volt and capacitor of 1 microfarad, and we are giving a square wave of 10 volt, where the maximum value is plus 10 volt, the minimum value is minus 10 volt. So 0 to T1 getting 10 volt, T1 to T2 are getting minus 10 volt. So now I want to find out what is the output voltage. So as I told before, the capacitor will only charge when the diode is forward biased. And when the diode is forward biased, when I'm giving this input waveform, when we have a positive half cycle for this particular circuit. So before finding out what is the capacitor voltage, let me find out the generalized equation for the circuit. So you can see here the voltage drop across capacitor is Vc, and as we have 10 ohm and this diode 2 volt connected parallelly, the voltage across that also V0. Okay, so applying KVL here, will get Vi minus Vc minus V0, or V0 instead of V0 or instead of VD you can write down minus 2 volt. Okay, so V0 equal to 0. Now I can write down your output voltage V0 equal to Vi minus Vc. Okay, so here Vc is unknown. Vc is unknown and we need to find out what is Vc value. Okay, as I told before, the capacitor only charge when the diode will be forward biased. So now in this input waveform, so the diode will be forward biased when we have the positive half. When we have the positive half. So when I have a positive half, I am putting this is, I'll put this side equal to positive and this side negative. If we redraw this diagram, I'll get like this. So the diode will be forward biased and short circuit. So let me redraw this diagram. The diagram will get like this. This is your Vi. This is the voltage drop Vc. This will be plus, this will be minus, and diode is forward biased, so only 2 volt left. This is your 2 volt, this is your Vi, or you can say that this is your Vi equal to 10 volt. As I'm taking the positive half cycle. So applying KVL here, will get 10 minus Vc minus 2 volt equal to 0. So voltage across capacitor I can find out here 8 volt. So voltage across capacitor I can find out 8 volt. So this 8 volt voltage I will apply in this output voltage equation. So our output voltage equation becomes V0 equal to Vi minus Vc. That means your Vi minus 8 volt. So V0 equation I will get like this. So as Vi is the input variable and it is varies with respect to time, so your output voltage also vary. So for different value of Vi, I will get different output voltage. So let us start with when Vi, if Vi equal to 10 volt. When Vi equal to 10 volt, so I am getting V0 equal to 10 minus 8, that is 2 volt. So this happens at t equal to 0. At t equal to 0. You can see here when the input voltage starting from t equal to 0, at that time the input voltage is 10 volt. I am getting the output voltage 2 volt. Similarly, if I'll put Vi equal to 0 volt, if I'll put Vi equal to 0 volt, I'll get V0, the output voltage equal to 0 minus 8, that is minus 8 volt. That is at t equal to T1, the result t equal to T1. I can see here when I'll put Vi equal to minus 10 volt, your V0 becomes minus 10 minus 8, it becomes minus 18 volt. So this minus 8 volt it will get in the range of T1 to T2. If you see in the diagram, when I am getting your input voltage basically minus 10 volt, at that time I'll get output voltage equal to minus 18 volt. So this range becomes basically T1 to T2. Okay, so I got all the relationship between output and input. So let me draw the diagram, the output waveform and input waveform by taking this table or whatever results I'll get. So this is your input waveform. This is a square wave having amplitude 10 to minus 10. It will vary. So this is your x-axis. I'll put 0, and this is the 10 volt, and the negative half it will be minus 10 volt. So from this relationship you can see here, if I want to draw the output waveform, so first let me draw the points. So this is your x-axis 0 volt. I'll put the marks like 2 volt, minus 8 volt, then minus 18 volt. So from this relationship, when you can see when the input voltage is 10 volt, at that time I will get output voltage equal to 2 volt. So output voltage I'll get 2 volt. So from 0 to T1 I'll get output voltage 2 volt. Then when the input voltage equal to 0 volt, at that time I'll get the output voltage minus 8 volt. So basically what this 0 line in the input voltage do, so here same thing for the output voltage, this minus 8 volt will do. Okay, so next when I'll put Vi equal to minus 10 volt, at that time I will get V0 equal to minus 18 volt. We can say that from T1 to T2 in this range I am getting the output voltage minus 8 volt. So after that this minus 18 volt will go back again, come to minus 8 volt. Okay, so this is basically T1 and T2. You can see it should look like symmetrical, but when I am drawing in hand, so it will not exactly look like symmetrical. But what you can see, if I can find out the first half, so peak to one peak voltage is 10 volt. Similarly, second peak voltage is also 10 volt. Okay, so for this positive half, I am getting here. You can see I can show you in the output voltage also the positive half. Similarly, for the second negative half, I can show you from minus 80 to minus 18 volt. So in both the cases, if I'll find out peak to peak voltage, I'll get 20 volt in both the cases. So here 10 minus 10 equal to 20 volt. Here also 2 minus 18 equal to 20 volt. So both the cases, the peak to peak voltage remains same, and the shape of the waveform also same. Only the waveform shifted downwards, the negative direction. That's why it is called negative clamper. So if I can exactly want to show you how the waveform look like, so I can show you in the blue color. So this is the our waveform, and I can show the 0 line, so which is in the input x-axis. So I can show you in the red color, it will be minus 8 volt. Okay, I hope you understand the numerical. If you like the video, then you can share with your friends.